Good morning, boys and girls. This is Mr. Giomini. Well, it is morning when I'm making it. Who knows what time it'll be when you're viewing it. I did want to talk about the scientific notation skill on Khan Academy. Some of us are having a little bit of difficulty with this, so I thought I'd give some examples. Now, the first thing it says, express this number in scientific notation. Before I even begin this, I need to remember that so scientific notation really has two things in the expression. You have a value here, which we'll call m, times 10, it's going to always be times 10, and to some power, so I'll call that p for power. Okay, a couple things I know. This exponent here could either be positive or negative, and that really depends on in which direction we move the decimal point. I know that this value here, this m, now the value m must be, so m must be greater than or equal to, it's an inequality symbol I just made there, greater than or equal to the number 1. But m must also be less than 10. So when I'm doing scientific notation, I'm always keeping this in mind. And then I always know that with scientific notation, we're multiplying 10 to some power. And we have to identify the exponent and determine whether it's positive or negative. So let's take a look at this first one. Let me get rid of this stuff real quick. So first of all, I see this number, and I'm going to rewrite it right here because it's kind of small. So click on pen. We have, let's see here, tenths, hundredths, thousand, 10,000, 100,000, and millions. So that's 2,179 millions. Okay, now, right now, I remember, in scientific notation, the first value has to be a number that's greater than or equal to 1, but less than 10. So I'm going to move this decimal point. I need to put it in between two digits that are not 0 for right now, because if I put it here, it's still less than 1. I have to have it greater than or equal to 1. So that tells me I'm going to move it once, twice, and 3 times. So if I take a look, my number is now 2, and I must write all the, well, usually write all the digits to the right of that decimal point. Again, if they're all zeros, then I don't, but in this case, they're not all zeros. So I have 2 and 179 thousandths now. So that number is greater or equal to 1, but less than 10. Now I'm going to put a multiplication symbol, I'll use a dot, times 10. Now here's the tricky part. I'm actually taking this value and making it this. Okay. Now the first thing I notice, in the ones place I have a 2. In the ones place here I have a 0. So this is a 2. In the ones place this is 0. So my number actually from here to here became smaller. When something becomes smaller in scientific notation, we're going to use a negative exponent. And now if I take a look, how many place values did I move it over? I moved it over 1, 2, and 3. So it's to the negative third power. I go to type my answer in, 2 and 179 thousandths times 10 to the negative third power. Let's check my answer, cross my fingers. Hey, all right, we're smart. Let's try another one. Now this one says, hey, here it is in scientific notation. They want us to convert it. Convert is a fancy word for change. Convert it to standard notation. First thing I notice is I have a positive exponent. My number here is going to get bigger. So essentially this is 10 to the 7th, so that's a 1 followed by 7 zeros. 1, 2, 3, 4, 5, 6, and 7. So I am multiplying 8 and 86 hundredths times 10 million. So this number all of a sudden becomes 10 million times bigger. So obviously my number is going to get much larger. So again, look at the exponent at 7. It says, hey, just take that decimal point and move it 7 places to the right. Each one is a power of 10. So we move it 7 powers of 10 to the right. So if I move it over twice, it's now 886. But I need to move it over 7 places. Well, I've already moved it over twice. So I go 7 minus 2 equals 5. I will just now add 5 zeros. 1, 2, 3, 4, and 5. Now, in this skill, I do not need to put the commas in it. And again, I can always check the acceptable format. It says like an integer. I don't need to worry about fractions. So I'm going to put in 88,600,000. 1, 2, 3, 4, 5 zeros. Hit check answer, and I am good. Now this is going to reload and say I've practiced this. I'm good to go. Let me practice it one more time. Do a couple more here. All right. Now again, here's one expressed in scientific notation. I'm going to rewrite this number. Right now it is 0 and 10th, 100, 1,000th, 10,000, 100,000th, millionth, 10 millionth, 100 millionth. Let me just double check that. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, apologize, my 5s look like S's sometimes. Okay, where am I going to move this decimal point so that the first value in my scientific notation is greater than or equal to 1, but less than 10? And I'm going to times that by 10 to some exponent, some power. Okay, I could move the decimal here, but if I move it here, that becomes 41. That's greater than 10. So I must move it. See if I can get rid of that little decimal point there. Oh, put that 5 back there. It's going to have to go right here. So my first number in scientific notation becomes 4 and 151 thousandths. Now let's see how many places I moved it from here to here. I moved over 1, 2, 3, 4, 5. 5 places. Now, here's the key question. Going from here to scientific notation, converting it to standard, did I get bigger or smaller? In the ones place in here, this is a 0. In the ones place here, that is a 4. So from going from 4 to the ones place to a 0 in the ones place, and nothing in the tens or anything like that, this is getting smaller. So I know it's going to be a negative exponent. And this is 1, 2, 3, 4, 5, 6, 7, 8. Let's see here. How many places move? I got to count again. 1, 2, 3, 4, 5. Good thing I counted again. That's to the negative 5th power. So I have 4 and 151 thousandths times 10 to the negative 5th power. Okay, we'll do one more. Now this one I have a very large number. I have 43,930,000. And I need to convert this to scientific notation. Okay, so first of all, the other ones before we had decimals in it. This one has no decimal. Well, at least not one that we put. Remember, in all whole numbers, there really is a decimal at the very end. It's kind of like your middle name. We don't say it, but it's there. So what I need to do is I need to move that decimal point all the way to the left until this number, until I make a number, and I'm really focusing on these digits right here, digits, because there's no zeros. These are all zeros. I'm focusing on where can I put that decimal point so that my number in scientific notation, that first value in that expression, will be greater than or equal to 1, but less than 10. And I'm going to place it right here, because that'll give me a 4 and 393 thousandths. And now I'm going to times that by 10. Now here's the part. I went from essentially a 4 in the ones place, nothing in the tens, hundreds, thousands, to a 43 million. So obviously I became larger. So in the previous examples, we always had a negative exponent because going from scientific notation to standard, we became smaller. Now going from scientific to standard, we're getting much larger. So now I'm going to move that decimal point. Let's see here. I like to cross out. Some people like to do the little loop unders. It's 1, 2, 3, 4, 5, 6, and 7. So it's 4 and 393 thousandths times 10 to the 7th power. Again, 7th power, I'm multiplying this by 10 million. So this number is 10 million times as big as this one, if I think about it that way. So 4 and, I should say, 393 thousandths times 10 to the 7th power. All right, I hope this helps you out a little bit with the, let me see if I'm right. Scientific notation, both for Khan Academy and also for assessments and things of that nature. Take care.